Hello. In this video, we'll be talking about the JSON file format. JSON stands for JavaScript Object Notation and is a very common format for data that is shared on the web. The reason is that JavaScript is a very common language for creating web applications, and therefore JSON tends to be very portable between different web apps. It's also relatively lightweight and can be easily sent over the internet from one application to another. When we talk about interacting with APIs, such as the Twitter API or the Google Maps API, we often receive data from those APIs in the form of JSON. Just like CSVs, JSON files are text that are structured in a particular way that our interpreter can parse into a data structure. And JSON files are structured essentially as a set of nested dictionaries and lists. So we're going to make an example illustrating what a JSON file might look like, and then we'll also check out a real example downloaded from the internet. So why might we want to use JSON as opposed to a CSV, all other things being equal? If we get to decide how to represent our data, what's the advantage of choosing JSON other than the portability I mentioned before? One major advantage of JSON is that it doesn't have to conform to a tabular data structure. Earlier, when we were looking at the CSV example, if this kind of model works fairly well so long as, having, what I mean by this model, what I mean is having the data structured as lines in a text file where each value is separated by commas works fairly well as long as the data has a repetitive structure where we can be guaranteed that each comma-separated value has the same meaning. In other words, the file should be structured like a table. As long as we can interpret the CSV as a table, it makes sense. The third comma-separated value should always be the age in this case. The second one should always be the name. But sometimes this assumption breaks down, or it's not easy to represent the data in this way. I'll give you the following example. Imagine that we are in charge of a library, and at our library we have a variety of books. Each book we have several copies, which may or may not be checked out, and may have different ages, depending on when they were published or printed. Certain elements of these books will be shared for all the copies. So for example, our first book is going to be The Prophet by Khalil Gibran, which is a book of poetry. And Gibran was a Lebanese poet. He was a mystic, so we associate some tags with this book: religion, spirituality, philosophy. Already we have a break from the tabular structure. How, in a table, would we represent a list? It would be very difficult. And additionally, we have multiple copies of the book, which themselves have several properties. The year it was printed, how many times it's been checked out, whether or not it's being currently borrowed. Our second book will be The Little Prince by Antoine Saint-Exupéry. And many of the properties differ from book one. Notably, there's a different amount of tags, and one of the copies of The Little Prince is checked out, so it additionally has a due date. It even has a new field that we had not seen before, and it's not present for all the copies. If we were trying to represent this situation in a table, we would have a lot of repetition and a lot of wasted space. Here's an example of representing even just these 4 copies of these 2 books in a table. We have titles and authors repeated multiple times for each copy. In fact, these first, not all those, these first 5 columns are likely to be repeated many times based on how many copies of each book we have. These last 4 columns are the only columns that are unique to each copy. Additionally, this last column, due date, contains many null values because it only applies to copies that are currently borrowed. So there's a lot of inefficiency in representing the data in this kind of table format. And that inefficiency is only going to get worse the more copies of each book we have, and the more books we have in general. So the format of these nested dictionaries and lists allows for a lot of efficiency by reducing the amount of duplicated data. To build our library, we'll put our 2 books in a list. And this is basically the format of a JSON file. Nested lists and dictionaries. We then decide how we're going to interpret these various nested lists and dictionaries as individual data elements. To parse JSON, both in reading and writing, we'll need to use a module. There's a number of different modules for parsing JSON in Python. The JSON module is included in the Python standard library, and we always have access to it. There's a number of others that we use elsewhere in the course, including simple JSON and UJSON. They have different advantages and disadvantages. I'm not going to get into the differences between all the JSON parsers. For the most part, the regular JSON package in the standard library will work just fine. To write JSON, to write our library, for example, to disk, we open a text file just as we normally would. Remember, JSON is just text structured in a particular way. And then to parse our object into the correct text format, we're going to use the JSON file to dump it to this particular file handle. So we dump this object into this file handle using the JSON module. This indent equals 2 keyword is just to set the visual style of the file. It ensures that the JSON file has this kind of representation where the elements are broken out line by line, and for each level of hierarchy, we have a 2-space indentation. That's all this indent2 does. So we see on disk our library data structure looks very similar in textual representation as it did working with it in the Python interpreter. To load this file back in, we open the text file for reading and use the JSON module to parse the file back into a data structure. So here is our reconstructed library, just as it was when we created it. In fact, we can check if these two things are equal, and they are. So we're able to write and read in this these lists and dictionaries just fine because our JSON module is able to parse that data structure into and out of a text file. We can even open up the library file on disk, and we see here the actual text file itself. We can edit it just as text if we wish. I know I'm emphasizing this a lot, but we should remember that a JSON file is simply a text file. If we simply read the text file, we end up with a string. So we can see here this string of JSON where we have all kinds of new line characters separating out the various lines, all these delimiters for indicating the beginnings or endings of lists and dictionaries. This is not what we want. It's a string. It would be very difficult to work with. However, there is a loads method as well as a load method that works with a string of JSON. So we could also parse that if we wanted. Just to emphasize this even further, the type of library string is string. The type of JSON.loads library string is a list. We've parsed that string into a data structure. Pandas also can read and write JSON files. However, when reading JSON, pandas will try to parse the JSON into a data frame, into a tabular format. So remember what we said earlier, that data may not be well represented in a tabular format. Here we have no duplication of our data, but these columns contain hierarchy. They, if we ask about what's in the tags column, we're going to get a bunch of lists. Or in the copies, we're going to get a list of dictionaries. So this may not be a very useful table that is constructed. Not all JSON files, some JSON files, rather, are tabular. So we can represent tabular data in a JSON format as well. So sometimes reading JSON into a pandas data frame will work very nicely. Other times we'll get something that's not very useful. I mentioned earlier that JSON is a very common file format that you'll receive when connecting to various applications on the internet. We can actually use Panda's read JSON method to download data directly from some URL or an API connection. Here we connect to the GitHub API to read the first 5 issues from the Pandas repo. And we get a table that has things like the body of the issue, the number of comments, the number assigned to the issue, whether there's a linked pull request, all sorts of useful information about the issues associated with this repo. In the next lecture, we'll talk about file compression and working with compressed files.